Hi there, let's finish doing this question. We got cut off last time. So we have two beakers. One only has 100 mils of water. The other beaker has double the volume, so 200 mils. And this one is at 10 degrees Celsius, but this one's at 50. Incidentally, which one of these has more heat energy? It's pretty close. There are less particles in this one, but they're moving faster. They have a higher temperature. There are more particles here, but they're moving slower. So we have to take both volume and temperature into consideration. So overall, this beaker is more than double the temperature, but half the volume. So it would have more heat energy. Okay, that would be like compare an iceberg, which is massive, to a flame, a candle flame. Which of these two have more heat energy? Well, the iceberg would have way more heat energy because it's huge. Even though the candle flame's probably at 300 degrees Celsius and the iceberg's at like -4, because the iceberg has so many more particles, it has more heat energy. Next. Two graphs below show the volume of liquid in a laboratory thermometer during a temperature. Which graph is a warming curve and which graph is a cooling curve? Well, we've talked about this before. When we take a laboratory thermometer, here's the bulb. That's kind of the brain. Okay, that's the bulb of the thermometer. And we have liquid alcohol in it. And we have a little bore, little tube inside. As the thermometer heats up, the liquid alcohol starts to expand and it rises. Okay, the volume of the alcohol rises. So that would be like what's going on here. Graph B is heating up. On the other hand, if this thermometer was cooling down, the liquid inside would start to go down. It would contract. And that's what this is doing. The volume is smaller, it's contracting. This one, it's expanding. So here the thermometer is being heated. Here the thermometer is being cooled. Last question. We have two pictures here. Bridges are made from material that contract and expand. The photographs below show an expansion joint between components of a bridge in winter and in summertime. Which season is shown in each picture? Explain how you know. So what do you notice here about the spaces between the bridge? So one section of the bridge and here's another section. The space is pretty big. So there's a large gap there. Here it is again, bridge side 1, side 2. And what do you notice now about the space? Okay, it's a small gap. So this is probably in the summertime where the bridge deck has expanded and stretched out, pulling away. And this is probably in the winter when the bridge deck has shrunk and contracted. Why do you suppose concrete roadways and sidewalks are laid in sections with grooves between them? So we have a sidewalk, and then we have a little space, or groove, and then we have a sidewalk, and then a little space, and so on. And the reason there's a little space there is, again, if during the summer, here's what would happen. It's going to stretch out the concrete. And if they both are right up against each other, it buckles. Okay, it heaves. Unless we leave spaces. So in the winter, we leave spaces because things contract. And in the summer, we leave spaces because things expand when they're heated. Thanks for listening to the answers to your review.